Good afternoon, everyone. My name is Mohsine Taarji. I'm a PhD student in electrical and computer engineering, and today I'm going to go over an introduction of deep learning. In this presentation, I'm going to go over what is deep learning, what is the difference between machine learning and deep learning, what is the concept of deep learning. I'm going to go over some applications of deep learning, what makes deep learning a state of art, what is inside the deep learning. We're going to do binary classification, multi-class classification. We're going to go over some activation functions and how deep learning works. We're going to also go over an example using AlexNet. And finally, we're going to see some tips of training deep learning. So the first question is, what is deep learning? So deep learning is a type, we covered last time machine learning. So deep learning is a type of machine learning in which a model learns to perform classification. Tasks like from images, text, or sound. So what it means, the word deep learning? So we know that deep learning is working neural network. It's a neural network. By deep, that means it's the number of layers in neural network. So more deeper, more layers on neural network. So over here we have a picture that shows the difference between machine learning and deep learning. As we see, machine learning, it has an input, feature extraction, classification, output. And the feature extraction, it's separated with the classification. Other than deep learning we have an input, feature extraction and classification in one part, then output. What does it mean? Both of them on the same part. That means the system, it's learning from itself, it keeps learning from itself. But machine learning, you have to give some feature, and it has trial and error. Every time you have to change the features, it has to learn from itself. And over here in this table, we see the difference between both of them. So machine learning, it only needs small data. But deep learning, it needs a lot of data if you want to train. So machine learning, it's quick to train, but deep learning computationally intensive. So as we see on the picture, the machine learning has the feature extraction and the classification separate, but the deep learning has both on the same time. And the accuracy is latest, but on deep learning, the accuracy is unlimited. Let's see the concept of deep learning. So over here, the idea is we have an input, we have an output, and we have a deep neural network. But what is inside deep neural network? We have a training data, and we have some rules. What it means is that we have, like we saw in neural network, we have an input, an output, and inside we have some neural network, some hidden layers. The same thing over here, but instead of having one hidden layer, we have multiple hidden layers. Let's look at some examples of deep learning, where we can use deep learning. That's a good question. Nowadays, deep learning, it's everywhere. You can see it in internet and cloud, like image classification, speech recognition, language translation, language processing, and etc. Even in medical field, we have the cancer cell detection, diabetic, we have and drug discovery. In the media, we have video capturing, video search, real-time translation. Also, we have it in security, like face detection, video surveillance, and satellite imagery. Also, nowadays, we have the autonomous vehicle. We have it detecting the pedestrian, the line tracking, and recognition of the signs. Those are some applications that we do every day. Like now, we see that self-driving cars like Tesla and everything. So we detect the signs, we detect the pedestrian. Also, there's another thing, it's the ATM machine. When you go to the bank and you put your check, by your check it's handwritten, how the system recognizes your handwritten. So behind that, we have a deep learning network. Also, we have a smartphone application to recognize your voice and translate it to another language. Let's look at some videos that explain about deep learning. So the first one, it's a game that's using deep learning, and we're gonna see how the system gonna learn using deep learning. Minutes of training. So the system, it's learning by using the training. And now they're gonna change the time of training. They're gonna upgrade it, and we're gonna see how the the player gonna start playing differently. Now it's 120 minutes of training. So it play like an expert now, if you see. But next, they're gonna also add more training. And what's gonna happen is, it's gonna beat the system. It's gonna win the game. So by deep learning, it's gonna learn all the tricks and it's gonna beat the game. So with deep learning, it's learned from itself. Each time you train, it's gonna learn and it's upgrading all the time. I have another one that's this
工作、回家，
one is
对他们而言，生活仿佛永远是一条循环的直线。颐和园选址在风景如画的北京西面郊，世界很大，生活很小。
Do Light 已开启。维他命果汁。纯牛奶。绿灯向前直行，通过斑马线。顾客徐辉。人民币100元。17孔桥，桥上石雕极其精美。
独立、融入、感受、骄傲、传递，无论是谁，都是平等的。Daylight 带你看世界。
So as we saw in this video, using deep learning, it learned we have the signs, the pedestrian, so it's the camera see the things and let the person know about what's going on.
Yeah.
So let's see what makes deep learning state of art. Is we see this chart. Deep learning started around 2012. It was back in the days, but because now we have some upgraded laptops, we start seeing more training because we need a lot of data and more training data. So if we see on this chart, with machine learning, the error was really high. But when we start introducing the deep learning, the error start going. We have the human error over here, and we see that's the deep learning start beating the human error. So deep learning start being better than the human. Let's see inside the deep learning how it looks. We saw the neural network. Neural network has an input, hidden layer, and output. As we see over here, we have the same thing in input, but we have multiple hidden layers, not only one. But as deep we go, more layers we have. We have an output. Also, we have this one, we call it neuron, and we have a weight and bias, as we saw in neural network. Let's see what is the difference on non-deep feed-forward neural network and deep. If we see the non-deep, it only have one hidden layer. It can also have none. It can only have inputs and output. But when we see deep neural network, it has inputs and hidden layers, more hidden layers than an output layer. So we saw that in deep learning we have classification. So let's start with the binary classification. So let's take two classes. We have triangle, and if it's triangle it's 1, if it's a circle it's 0. Let's see a real-time example. Like we have cats and dogs, and we want to do binary classification. If it's a cat or a dog. If we see over here the feature, the cat feature, it's different than the dog. If you see the ears. The cat has like a triangle on the ears, but the dog has the flat. So that's how we recognize. So because we have two classes, we're gonna have two parameters of input and we have output. The output is gonna be either a cat or a dog. Either it's gonna be the triangle or the circle. So how our neural network gonna look like? We're gonna have two inputs and we're gonna have one output. And we have a hidden layer, and they're all related to each other. So for the training, we're gonna have two inputs, but our output is gonna be either 1 or 0, either a cat or a dog. How about if we have more to classify? We have 3. So how gonna be our output? We have triangle, circle, and rectangle. So let's get a real example. So we have 3. We have car, we have a deer, and we have an airplane. And we want to classify 3 of them. So how you think the class is going to be looking like? So the first thing, the training, we're going to have 2 inputs, and we're going to have an output, either class 1, class 2, or class 3. So our neural network is going to have 2 inputs and 3 outputs, because we have class 1, class 2, and class 3. So how class 1, class 2, and class 3 are going to look like? If you see, it's going to be either 1, 0, 0, 0, 1, 0, 0, 1, or 0, 1, 0. And that's what I'm going to explain now. So this one, the class 1. So it's going to be the class 1 is 1, the class 2 is 0, and the class 3 is 0. And if we see on the next one, that's how we define the numbers. So if the first one, we want a class 1, the class 1 is going to be 1, class 2 is going to be 0, and class 3 is going to be 0. But if we want a class 2, we have to make class 1 and class 3 0. If we want a class 3, we have to put class 1 and class 2 0. And if we have more, so we put the other one, the other class as a 0. So for the deep learning, we're using as a activation function, we're using softmax function. So how the softmax function look like? So this is the general formula. It's exponential of the local field over the sigma of the exponential of the local field. So it's a generalization of logistic function that we covered last time. So if we look at it in another word, the sum we can put as an exponential of all the local fields that we have. And we're going to have a real example over here. If we have 3 outputs on the local field, so we have 2, 1, and 0.1. So what we're going to do is when we put the formula, which is the sum, which is the exponential of the initial over the sum of all of them. So that's the same thing. We put the exponential of the initial over the sum. And that's the vector that we get. That's the... So over here we have some activation functions that we covered last time. So we have unit step, and also we're going to use the sigmoid function that we explained last time. So what is the training process if we want to train? And this one, we're going to duplicate it in the code that we're going to look later on the multi-class classification. So first, we have to define the output nodes. Second, we have to define the classes. What is the, like, if we have 4 classes, it's going to be 1, 0, 0. So it depends on the classes that we have. The third thing, we have to define the weight, to initialize the weight. Then we have to calculate the error. Then we have to do the back propagation. Then we have to update the weight. And we start repeating till they get the good results. Let's get some real example. So we want to define, we have how many classes over here? We have 5. We have 1, 2, 3. Those are the classes that we have. So how our network gonna look like? If we have 5 classes, when we saw 3, we have 1, 0, 0. Now we have 5. So we put the first one 1 and the rest is 0. On the second class, we have 1, the rest is 0. And the third one 1, the rest is 0. And so on. So for this example, we use in the sigmoid functions, which is 1 over 1 plus exponential of minus x. And we use in a softmax function that I just explained. Let's go. Run the code. So in MATLAB,
the code should be available in Canvas.
let's go first. So the first thing we have to define, because I'm doing a code for multi-class function, so the first thing we have to define, what is the function multi-class? We have to define. So the reshape, it's the function reshape, it's for the importing the inputs from the training data. And we're using, as I said, the sigmoid function and softmax function. We're doing the error, calculating the error. The D, it's the output minus what we get from our system. So here we calculate the error. So the error, it's what we want. So that's our output, it's the D, and minus what we get from the system. Then we calculate the delta and we update the weight. So for that we're using also the sigmoid functions that we looked at. It's 1 over 1 exponential of minus x. Then softmax function, which is exponential of initial minus the sum of exponential. And here it's our test function, which I'm going to run in a little bit. So let's look at the first one. It's a x of 1. So how the first one going to look like? So if you see over here, whenever you have 1, that's the pixels that we have on our image. So we're defining 1, and we want to get the output, how the system going to recognize our output. Let's go back to code. So we defined 1 and 2. If you see the 2, if you draw it, it's going to be like a 2, 3, 4. That's our initial. The D is our output, like we said. That's what we want. We wanted the first one to be on and the rest is off. And we put the weight as a random. Then we trained the system. And then we did the sigmoid function, the softmax function. Let's go ahead and run our code for the first one. So if you run it, that's what we get. We get the first one, number 1, it's recognized at 100%. And it recognized the other ones as 0%. And for the second one, it recognized the 2 as 100%, but the rest it's recognized as a 0%. It couldn't confuse none of them. It only recognized the 2. And the 3 and the 4, it recognized them as 100% perfectly. So now let's do like real numbers. Instead of having like, the shape of 1, we're gonna trick the system. Instead of having the 1 like perfectly, 1 over here, we're gonna trick the system. We're gonna go like this and have some number. It's between 1 and 4. It's not really like a 1 and it's close to 1. The 2, it's a little bit different. The 3, and we want to see if the system gonna recognize it 100% too. Okay, so let's first run the code, and so if we run this code, we're gonna see that number 1, it recognizes it as a 2 with 100% accuracy, 99.36% accuracy. For the second one, it recognizes it as 3 with accuracy of 97%.
So to scroll on.
Yeah,
You're missing one. Scroll on.
yeah, it's here. So 1, it's recognized because we saw the shape. It's looked like a 4. Then the second one, it's recognized it as the 2. So the second one, it's perfect. The third one, it's good. And the fourth one, it's recognized it as 3. And the last one, no, the fourth one, it didn't recognize it at all. It was like 5, and the accuracy was 50%. And the last one, to recognize it pretty good. So let's look at here. So if we see the left image, that's the image that we choose as an input. We're trying to trick the system. If you look at the image, it's looking like 1 and 4. So it recognizes it as, instead of 1, it recognizes it as 4 with 96% accuracy. The second image, we trick the system, we add this one. So to look like in between 8 and 2, so the system, we can trick the system. But it recognizes that for 99.36%. We look at this one. It looks in between 3 and 2, but it recognizes it as 3 with 97%. Also the 5, it recognizes 3 or 5 with some accuracy. We saw that's the accuracy, 50%, 32%. So it's not sure about what is the accuracy. And the last one, because it looks like a 5, it's recognized as 5 with 98%. So we have how a deep neural network learns. So for that, and this one it's an example from AlexNet. That's behind the AlexNet, that's what we have inside. So they're using convolutional neural network as a function. They're using a Rulu, and which we're gonna cover later, and they're using a pooling. And they have a fully connected function. They give an image as an output, as an input, and they wanna recognize it as an output. But for here, they have to filter it, they have to resize the image, and they have to do other things. So how to improve our deep neural network? We have 3 things. We have vanishing gradient, we have the problem of overfitting, and we have computational load. So what is vanishing gradient? So if we see on the pictures, our input and first layers unchangeable, we just update the outputs and we keep updating to get the accuracy, more accuracy. For that, we're using the ruler function. If we see the ruler function, before 0, it's 0. But after 0, it's a run function. So that's why we have an x and we have 0. That's our function over here. So f the x, it's the max of 0. And so we're using also the derivative of it. So because we have an x and 0, we're going to have the derivative going to be 1 and 0. So we have the problem of overfitting. So over here, the most solution, the representative solution is they're using the dropout. So what we can see it on the pictures. So the dropout, it's when they use for the training, they use which train only some randomly selected nodes rather than the whole neural network. Instead of taking the whole neural network, they're taking just some and they train on them. So that way they save sometimes. And the dropout effectively prevents overfitting. It continuously alternate the nodes, weights in the training process. So here, as I talked about just a minute ago, it's the AlexNet. AlexNet, it's a preprocessed neural network that they already trained a lot of data on it. You see over here, all this been trained on AlexNet. And they say it's 1,000 different categories that's been trained on it. Let's see a real example on AlexNet. So over here, they want to do with the real time, like they call in a camera. Then next line, they call in the neural network AlexNet. Then they take in snapshot. And AlexNets only work with 227 by 200. So they're resizing the image, then classifying it, then labeling the image. And next we're gonna see a video that's demonstrate.
Hi, my name is Joe Hickman. I'm a senior developer at the MATLAB. I've been experimenting with deep learning with MATLAB and the Neural Net Toolbox. I've written a simple little program that does something pretty cool. I'd like to show that to you now. What I've done is I've taken a webcam and attached it to a neural net that recognizes images. So now I can point the webcam at various objects and it recognizes it. A corkscrew or maybe a screwdriver or perhaps a revolver, a harmonica, a teapot, a shovel, that sort of thing. It's not perfect, but it does a pretty good job. So let's look at the code that does this. This is the whole program right here. It's just 11 lines. We're going to go through it, but we're going to do it in 3 separate stages. We're going to clear the workspace. We're going to ask the camera to connect to the webcam, have the camera take a picture, and then finally show that picture on the screen. So when we run this, we should get a fresh picture going on here. And that's the picture we just took. Right? But that's a still image. We want this to be in a continuous video. So we're going to add 3 more lines and put it in a loop. We'll put a while loop around the code that's was taking the picture, and we'll add a draw now so MATLAB draws immediately. When I run this, we'll get the same thing, but now it's a live video. All right, finally, we need to add in the neural net. I'm using a network called AlexNet. AlexNet is a large, deep, convolutional neural net. They trained this network on over 1 million images, and it can recognize about 1,000 different objects. I've downloaded it, and now we're ready to use it. This line is going to ask the network to classify the picture we just took. So we'll pass each picture to the network, and it will return a label of that picture. Before we do that, we have to resize the picture to the size that AlexNet expects. It was trained on a particular size of image. Finally, I'm going to use that label in the title of my picture, and I've got to convert it to a string with this command right here. So we're all set. Those are the lines. Let's run it again, and we're running again. I can recognize the keyboard, or maybe a space bar, recognize my mouse, or maybe it's a spatula, and there we go. I hope the simplicity of this program encourages you to try out deep learning. The next natural step would be to try transfer learning. Transfer learning is where you take a network like AlexNet and retrain the last few layers on your own particular images. That will result in a network even better than AlexNet.
So next, that's what we're going to see. So how about if we don't have those images on our AlexNet? What are we going to do? So over here, that's what he just talked about. We have to retrain the system. So over here, we call in the AlexNet. We define in the layers, and we call in the folder. We put the image that we want, and we put them in a folder. And we use some subfolders if we have other images. Like if you have flowers, and that's when we did the deep learning from MathWorks. That's what they have. They have a folder of flowers, and inside that folder we have subfolders with different kind of flowers. And then you start training, and you predict, you classify, and you say what is the accuracy. So the same thing, if you don't have, that's how you're going to do it. So finally, Andrew Neg gave it tips for the neural network, for deep neural network. What he said, if does it do well on the training data? That's a question that he gave. Is your system does do well on the training? If it does not, you have to make your neural network bigger. And if yes, you have to go and if you start testing, is your data enough? It's not enough, you have to add more data. If it's yet enough and you get what you want, so you're done with it. Thank you.